Here we go. So guys, what does a integral do directly? There was a question, a bonus question about tell me 2 ways to look at an integral. What does it accomplish? What does an integral accomplish?
What is it? Integral?
Yeah.
It gives you the area under the graph.
Gives you an area under a curve. Yes? What that curve represents could be multiple things. In fact, we've seen that if I can express the volume of something in terms of one variable, it becomes a one-dimensional integral, which is trivial. So I could actually use an integral, one integral, to get the volume of something. But that's only if it's a repeated shape, like I have a shape when I rotate it. Are you guys all with me? So one thing Calc 3 does is it says, okay, what if you didn't rotate it? What if it's just this three-dimensional freaky blob thing? Calc 3 can handle that, because in Calc 3 you learn about double integrals, triple integrals. So then you can go the x direction and the y direction and the z direction and scan a whole thing. Okay, I don't know if you guys are with me or not. That's just in your future if you have to go that far. Chapter 8, the first thing it does is really, really silly, unbelievably straightforward is what I hope. Let's see. So here's the one thing. This is the one thing I'm going to talk about from chapter 8. Say I have a function there. Look, yay! And it goes from A to B. And if there's like any picture that somebody would draw that's like, what did your teacher draw the most in calculus? It's basically this. I drew some version of this a lot. Now normally what would the next thing be that I would say? With a picture like this, what do you guys think this would represent? What would I do with this?
Draw rectangles?
Yeah, I could draw rectangles. We try to find the area underneath the curve, yes. But no, what we're going to talk about right now is, well, how long is this curve? Very different question. You guys got all with me? Can you see why that is not an easy question? I mean, if A is 1 and B is 7, if this thing was straight, the length would be 6. Right? From 1 to 7, the length is 6.
But we don't know how long it is.
But this thing is constantly turning, yes? Are you all with me? A little bit, maybe? Screw each other? If only this was like a semicircle, then I could just do a circumference and cut it in half. But it isn't. It's a wobbly little dude, yes? It's a spaghetti noodle that fell on the ground. Poor little dude. Okay, so this is one of the coolest. So I want to get the total length of this. So you might wonder, how would integration help with that? Dear God, Jeff. But let me expand your idea of integration. So we first investigated integration to help us get the area. And we started with drawing rectangles, and then eventually we got the infinite limit, and then we replaced that with the integral symbol. What integration does more fundamentally is it's just adding when I have an infinite number of things to add. Are you guys all with me? It kind of is able to do that directly. And that's not an easy thing. But you said, hey, how long do you think it would take you to add an infinite number of things? You probably go, forever, and we've done it many times now. You guys realize that? Every time you've done an integral, you've added an infinite number of things, basically. Okay. So, here's the thing. Where's the infinite number of things on this? What is it that I want about this line again? About this little curvy dude? The total length. I want to calculate total length. So if I want to calculate the total volume, let me see if anybody was really paying attention when we developed this. If I wanted the total volume of something, I actually always did the same thing. I first wrote an element of volume, a dV, and then we added those up. So if I want to know the total volume, if I can represent dV, I can then I can integrate dV from A to B, or whatever represents what I'm trying to do, yes? So here I'm trying to get the total length. So therefore, I'm going to take this segment, I'm going to take this curve, and I'm going to break it up into an infinite number of little lengths. What good is that going to do, Jeff? Well, here. Would this be an easier
example of a question. Would you guys be able to figure out the length of that?
Yeah.
How would you do it?
You just
Set up a triangle.
Yeah, totally, right? Okay, real quick. Believe it or not, this is going to immediately apply to this in a minute.
Oh.
What's this?
triangle.
In fact, let me ask you in symbols. What is the change in x?
3.
3. And what is the change in y?
2.
2. So then how would you get the length?
Pythagorean theorem.
Pythagorean theorem. So the length would be the square root of delta x squared plus delta y squared. Yes? You guys are all with me?
So round 13.
Yeah, in this case, it would be, yeah, rad 13. Cool. Okay, 11. So here's how this applies. As long as the function I'm given is continuous, differentiable, I could do this. In fact, most theorems we see in calculus requires my function to be continuous and differentiable. If my function is continuous and differentiable, what happens to it if I zoom way in on a piece of it? So if I take this piece right here and I zoom in on that piece, what should happen to it when I zoom way in on it? What should it look like?
Pretty straight, very straight.
It should look like a straight line, which is what the tangent line overemphasizes for us, so we can consider, oh, this line is like that right there, but we just draw it forever just to kind of like make it easier to see. Let me stop for a minute. You guys are all with me? I understand. Some of you guys are like, I'm not listening to you, Jeff, because you told me this is not going to matter. Like, damn it, just take a second. We're almost done. So if I take this little piece and I blow it up, it's going to look like a little line segment. Now here's the trick. How long is this? Considering, let's pretend like this is an infinitesimal piece. This was delta x. This will be what? Dx. And what's this? Dy. So what's this length here?
dy over dx.
No, that's the slope. I want the length. We just did the length. We do it again, but this time instead of delta.
Just ride it.
Yeah, it's the same idea, right? It's just this guy was a macro triangle. You guys cool with the word macro? Big. It's a big triangle. This guy is an infinite number of infinitesimal triangles. So it's really neat how they fundamentally work the same way. This one I can do on a macro scale because nothing changes. It's a constant movement. This one I have to do it on a micro scale because it's constantly changing. So this will be the exact same thing, which is silly. A little, let me be careful the way I do this. A little length element is going to be the square root of dx squared plus dy squared. Now, see if you guys are really paying attention. If I just integrate both sides, can anyone see anything wrong with either side? Like if I write an integral on both sides, if I just add an integral symbol, I'm going to add them up. Does this guy look like a valid integral?
Yeah.
Yes, of course it does. Why? What's it got?
The DL.
It's got an integral symbol, it's got a DL, and in the middle it's got 1. So what's wrong with him?
It doesn't have.
Yeah, one consideration is 2 variables. More immediately, do I have a complete integration symbol?
No.
Do you guys see that? The D something is missing, correct? So this is the last step. Yes, this is the last step. It's really silly. It's stupid awesome. All I'm going to do, let me see if you guys are cool with this. I'm going to factor a dx squared out. And another way you could see that, I'm going to take a square root of dx squared out. And one way you can consider that is if I multiply by this, is that okay to do? Because what is this? 1. So I'm going to multiply this by 1. When am I allowed to do that? Any damn time I want to. I'm going to keep this guy out and I'm going to bring this guy in. What is dx squared divided by dx squared? What's dx squared divided by dx squared?
1.
1. What's dy squared divided by dx squared? And now and what's the square root of dx squared? Dx. So now does this look like a normal integral? What does this say? Whatever function defines this, I throw its derivative here. I add 1, put it under square root. Funky. I don't blame you if you didn't really follow me the whole way, but it's just so silly because when you first think about how do I get the length of this stupid thing, how would an integral help with that? Integrals are area. No, integrals are adding infinite things. So I have an infinite number of little elements of length, and if I add them all up, I get the total length. So a lot of mathematics is focused on how do I represent d something, little elements of this, because then I could just set up an integral and get the freaking answer. Okay, maybe. All right, that's my little thing about chapter 8. Just in case you guys get to Calc 3, and I can't remember off the top of my head how this shows up in Calc 2. I think it does. It does in chapter 10, yes, a little bit. Just in case you get there, you'll be like, I think I've seen something related to this. But start over from the beginning. But at least you have a little something, yes? Okay. That's the end of the new stuff. That was the last new concept of the summer.
Is that 6.5?
No, this is chapter 8. 6.5, I'm going to make that extra credit. All right, look. I do want to say one thing about 6.5 because it's such a cool idea.
6.5 was extra credit.
Yes, I said that in the email, didn't I?
Yeah.
Yes. Check your emails, kids. So let's say I have this, and I don't want to know the area of this triangle. I want to know the average height the triangle is. Y'all agree with me the triangle is 0 height here?
Yeah.
Y'all agree with me it's 4 height here? So it might be a good guess to say the average is 2. But how do you know that for sure? Yes? So here's such a cool idea. Here's, not 2, Jeff, what would it be? I don't remember. What was it, 0? Oh, 2, I said 4, but it's 2 here, so the average should be 1. So if I put a 1 here, do you see how if I just cut this off and put it here? You guys with me? Now, it's very hard to do that. I can't do that same thing if my function looks like this. Can I do that same thing easily? No. So I want to develop a way to do this. Can somebody tell me the area of this triangle?
4.
Yeah, 1/2, 4 times 2, 4. And let me ask you that this is really silly. I want you to notice something. If I take that area and I put it there, I end up with the height, right? And what shape did I just make?
Rectangle.
A rectangle. And what is the area formula for a rectangle?
Base height.
Yeah, that's right. Length times width. So base times height. I love it. Yes? Do you all agree that the area of the triangle and the area of the rectangle are equal?
Yeah.
So the area of the triangle is 4. That means the area of the rectangle has to also be 4. Yes? What's the base of the rectangle? 4. So if I solve, I'll get the height as 1. How do I do that with this?
Cutting.
No. What did I just do? I got the area of the original, didn't I? You guys with me? So say this is A to B. What's the area of this function? From A to B. What's the area? No, come on. We're in calculus. What's the area under that function from A to B?
Integral A.
Integral A to B. Yes. Okay. Do I know the length of the rectangle I would create?
Yeah.
If I did chop some of this stuff off and then fill in, do you guys see what that? So you see the idea is, I want to say, how much would I have to push it down so that it becomes a rectangle? Yes?
Mm-hmm.
Are you guys at all with me? So it's like, this is such a cool idea. So that's how I get the area. So I know the area of the rectangle is this. What's the length of the rectangle?
AB.
B
Or B minus A.
minus A. So if I divide, I'll get the height. The area of a rectangle is the base times the height. So what's the height? It's the area divided by the base. So if I want to know the height of the rectangle, it would be the area divided by B minus A, which is the integral divided by B minus A. This actually ends up being the average value of the function. And that's all section 6.5 is. This is the dumb thing. Have we done stuff like that before?
Yeah.
Shit, yeah. So look what 6.5 does. It says, do that and then divide by B minus A. Ooh, that's why 6.5 is just a silly section, but I'm gonna make it extra credit because it is super easy. It's nothing really new. It's just do what we did and divide by a number. I think we could all do that. So I don't mind not making it officially do. If you have time, do it. It's easy. If you don't worry about it. It's not a big deal. Okay.
Are you still accepting 4.8?
I'm accepting everything.
Until tomorrow?
Yes. Just some of it will be late. Extra credit, normally I count it even if it's like late. You can still turn the extra credit sections in. Okay, so now based on that question, that is the final new idea of semester. So now the rest of today is going to be devoted to review. We can do whatever.
Review limit derivative.
On the final practice test?
Yes.
Final, number 2, please.
And what did you say?
Limit derivative by the definition of limit derivative.
Oh, okay. So yours is more like number 1,
Yeah.
and yours is number 2.
Yeah.
Okay. How do I do the limit definition of? I'll just do this in order. How do I do the limit definition of derivative? The definition of derivative.
F of x minus h times.
Huh?
Isn't that formula?
Nope. So what is it? I get it started. F of x plus h
Oh.
minus f of x all over h. If you do x minus h, things get a little weird. You have to divide by negative h. It just makes it worse than it has to be. You guys remember that?
Yeah.
I know it's been like
3 weeks.
it's less time than normal, but still a decent amount of time. Yeah, that's all that is, right? So don't do the silly thing about f of x plus h is just this plus h. That's silly. What is f of x plus h? What's the first level way to evaluate f of x plus h?
3x squared minus 2x.
No, that's f of x. I want f of x plus h.
Plug in x plus h.
Just plug in x plus h, right? What's f of 3? 3 times 3 squared minus 2 times 3. What's f of w? 3 times w squared minus 2 times... What's f of x plus h? 3 times x plus h squared minus 2 times x plus h. Don't make a bigger deal out of function notation. It's dumb. We created it. When I say dumb, I mean it's basic. It just has one thing it wants to do. Shove stuff into it. That's all it wants to do. So whatever I put into it, I put into it. Simplify this. Yes? The biggest mistake I see students make, just to cut to the chase here, the biggest mistake I see students make, I'm going to make a mistake. I'm announcing to you right now, I'm going to make a mistake. So here's f of x plus h minus f of x all over h. Somewhere I've made a mistake. There's f of x plus h minus f of x all over h. I have made a mistake. And it's really easy to spot. Because what's supposed to happen now? Go away.
Oh, the x
Go
was
back
supposed to
again,
cancel?
please. What's supposed to happen? H has to cancel. Yes, for very easy functions, the limit definition of the always has the same thing happen. The h, I can't plug a 0 in because the h is there. So I need it to die, and it will always die, especially with the functions we look at. Do you notice that these don't cancel? And that'll tell you, oh, you made a mistake. So what mistake did I make specifically?
You didn't properly subtract those functions.
Exactly. I'm supposed to subtract f of x. I'm supposed to subtract f of x. Now the 2x stuff will cancel, and I'll only be left with h stuff, so that I'm able to divide by h. You gotta love when the results of a math step tell you you made a mistake. They're like, hey, human. If you just listen to it, you go, oh, that's a mistake I made. Is that okay? And then you do it. And blah, blah, blah. Everybody cool with that to finish that out?
Yeah.
Who asked that question? You good? Yes? Okay. And then number 2, right?
Yes, please.
Oh, okay. Could you just attack this the way it is?
Yeah.
Of course you could. What kind of rules would you have to use to do?
Power rule. Or
2A.
chain rule.
Yeah, fundamentally it would be like a chain rule. You have natural log of stuff. The stuff is itself a chain rule, because then you have stuff cubed. Yes? That would work. Now obviously the tone of my voice is telling you that I'm like, why the shit would you do that?
Why don't you just move the
What
three?
could I do instead?
Move it
1
3
over.
I could bring the 3
to behind that.
down, because the rule of logs is if I have a power on the thing inside of a log, the power can come down because logs are powers, and then multiply powers when I raise
Wait,
something to
wait,
another
sorry,
power.
sorry, I did not mean to, okay, I meant the one with the tangent line, it's B, on B.
Oh, part B.
Yeah, sorry, I
Okay.
didn't mean to.
So 2A is just simplify first, right?
So at 3 natural log squared minus x.
1B, what would I have to do? I'd have to finish this out. Look. You guys can do the limit thing, yes? Yes? You guys could finish this, yes? Is that all right? Does anybody need to finish this? Here, we'll do it real quick. Die. Come back to me. Thank you. Is that cool? 3x squared minus 3x squared, negative 2x minus negative 2x. Okay, they're all gone. Everybody else just loses an h because everybody else is divided by h. And of course, when I let h go to 0,
Comes zero.
that goes to 0, and so I get 6x minus 2. And again, if I ask you to do limit definition of derivative for this, what are you going to do? First thing even,
Find the derivative.
find the derivative. So then when you're done, you're like, oh good, that's what I was supposed to get. Yes? I always get people make a mistake, and I'm like, don't use the mistake. You know what the answer is supposed to be. Use the answer. Okay, so now how do I do part B then?
Take the derivative
We just did.
and plug in along.
Yeah, so we know the derivative is 6x minus 2. What's the derivative's job?
Find the slope.
Tells us the slope, so if I plug a 1 in, it'll tell me the slope at the point that I need. What do you get? 4, and then what do I do? Do I have all the information I need to construct this
Yeah.
line equation?
Yeah.
Yeah, because all I need is a slope and a point. We just got the slope, I gave it a point.
Oh, that's it?
Yeah, and then what do I do?
Y minus
Y minus y1 equals m times x minus x1. You could still use y to the minus z and solve for b, blah, blah, blah. Yes, just make sure your answer is a line equation, and you circle it. Okay. Is that okay with that one? Okay. Are there any other specific questions from number 2 that you want to look at? Okay. This might be a very quick day. Does anyone? If nobody's asking anything, the floor is completely yours. And if we're quiet for a few minutes, I'm just going to start to ask myself questions.
Did you do 2C?
Did anybody have a follow-up on anything, by the way, before I move on? All right, I'll come back to you in a second. Well, 2C?
Yes.
Yeah, what's going on with 2C?
A lot.
Yeah, just a bit. So what's the first level rule that we have to use?
Product.
Good, product. One of the functions that are involved in the product
I need a
will need a chain rule eventually, but that's not the first level. Of a function times a function, that's product. Yes? So has everybody tried this problem out yet? Go ahead. If you haven't done this problem out yet, try it out. I like how some of my powers are huge, some of them are tiny. Come on.
So,
Did I write on this? I did. Darn it. I didn't want to. Jeebus. I really zoomed in.
what you got?
So the first level
60.
derivative, if I just want to show all the steps. Just want to point out for a second, that's some of the best writing I've done the whole semester, which is still bad, but I saved it for the end. Is everybody with me? You can always do this. You can always just write the rule and then do the derivative next. And that's a really good idea because a lot of times with this very stuffed function, I don't want to try to carry the whole thing in my head. So what's this derivative?
60.
That's crazy. And then how does this guy work?
Just put that
Yes, sir.
times
Yeah?
2 minus 15t.
Right. Power goes down by 1. Good. And that's just, of course, chain rule. Yes? And you knew from the beginning there was going to be a chain rule, but that's not the first thing. The first thing is it's a product. And now it's just clean it up, yes? The only real thing you could do is like, you could distribute this, yes? Or you could move this in front. I mean, I don't know. Even if you stop there, I wouldn't take points off, but, because nothing really cancels or anything, yes? You guys at all with me?
Yeah.
I don't know what I did on the answer key. We'll all find out later. Again, you could have a question from the last test, from the quizzes, from the first quiz, from the first test, from the first homework assignment, from the 8th homework assignment. I don't care, because it can come from anywhere. What you got, Nikhil?
Can you do 2D?
Oh yeah. So what's up with 2D? Same question, right? Find the derivative. Do I actually integrate in this problem? There's an integral right there.
Use
Do I integrate?
the fundamental theory of calculus.
Yeah. You don't have to know what it's what it is. But I'm asking you to take the derivative of something that represents an antiderivative. It should be relatively easy.
You just put
The reason it's not like completely easy is because integrals are a little weird. Plus, what's one other little thing you gotta be careful about?
chain rule.
There's a chain rule because the inside is x squared. So what's the first level of taking the derivative of an integral? Is this in the right form?
Yeah.
Why?
Because the constant is on the right.
Constant to a variable expression, yes? So it's in the right form. So f prime, what's the first level of doing this problem?
X squared cosine
Yeah.
h.
Cosh. You don't even need to know what that is. I can put whatever function I want to in here, to be honest. I can put function you've never seen before. And you don't care, you just gotta write it again. Throw an x squared in there, yes?
Times.
Good? Yeah. So this is the rule for derivatives of integrals, and this is chain rule. Now, there's one little thing you could do that's very simple to simplify this a little bit, yes? What can you do? Can you multiply this by this?
No.
Of course not, because this is stuck inside. What can you multiply this by?
By x squared.
Yeah, so you can put in front 2x cubed, cosh. By the way, this is hyperbolic cosine, which is from section 311, which we did not get to.
What is that?
What are trig functions based on, fundamentally?
Triangles.
Unit circles. And they're triangles that kind of, you realize later, they live inside of a unit circle, yes? Hyperbolic cosine sine are based off of hyperbolas instead of circles.
Wow.
Yeah. Some of you guys know about like square waves. You could create trigonometric ideas from different things besides circles. Alright, that's a little too much for right now, I'm sorry.
That's 2x cubed, right?
Huh?
That's 2x cubed.
Cubed, yes. What did I put? Cubed. Okay. Yeah, 2x times x squared. Let me see. So of course, if I would have had these reversed, you would have to first flip it and then introduce a negative. Good.
Can we do 6?
Anything except number 6. Oh no, that could be number 6. So, what's a first good thing to do? I would just rewrite this, right? Radical notation just generally sucks. And then, what's the idea behind implicit differentiation? What is the idea?
That you do what
You
you want. One side,
differentiate and
both
then put
sides.
dy.
I want one word, maybe two words.
Both sides.
Differentiate y.
Chain rule. That's all it is. It's
Sounds
just
like
chain
that's
rule.
word.
There's a function inside of a 1/2. There's a function of x inside of a 1/2 power. So of course chain rule is going to show up here, yes. So y is a function of x. Did they explicitly tell me what that y is? Nope. So it's implicit. So what is the derivative of stuff to the 1/2?
1/2 y is 2, 3, 2.
dy.
Yes. Chain rule. Yes. And then what rule do you have to use here? Product rule. So you can just write for yourself. You can even do this if you want to. Well, I could do by dx here. Then we could do product rule in a minute. Yes. Are you guys with me? I mean this. What's the derivative of secant stuff?
Secant stuff, tangent stuff.
Secant stuff, tangent stuff. Times?
1/2.
Nope. Yeah, inside function. Yes.
dy.
dy dx. And of course the derivative of natural log of x is? Yeah. So now you just take this guy's derivative, do product rule, distribute, get all your dy dx stuff together on one side. Yes. Yeah. Is that okay? The rest of this is, believe it or not, algebra. Except for this little piece right there. But number, which one? I'm sorry, 6, 7, 3. Oh yeah. When I give you a problem like this, do you see how the questions are position, velocity, acceleration?
Yeah.
So what's a really good first thing to do? How do you get the velocity given the position?
Take the second derivative.
Take the derivative. So the velocity would be the derivative of this, and what do you get?
18t minus 18 squared.
And what's the acceleration?
18 minus 8.
Yes, the derivative of velocity
Minus 32. 50.
plus. Now you can answer every one of these questions. Easy. The first two are stupid. Yes? First one, you plug a 0.8 into the correct function. I forget what's the position. I cut it off for myself. Yeah, position, so you put a 0.8 in there. Second one, velocity at point, okay, so put a 1.2 in there. You with me?
Yeah.
C and D are much more interesting. How the shit do I do part C?
The acceleration of the particle is not moving.
So just put
When
the acceleration formula and put t0.
Yeah.
Put the acceleration
No,
formula.
no, with the acceleration formula, just make t 0, so it'd be 18.
No, no, I didn't. Nowhere in there does it say or imply that 0 seconds have gone on. Nowhere in there. Yes?
Oh.
What do I want to be true in part C? What has to be true? Particle is not moving. If you're not moving, what do you know for sure?
Velocity
Velocity is 0. Now, real quick, let me ask you this. This is a weird question. Yeah, I need you.
Oh,
I'm not
set
going to
it
make this
equal
into a
to
physics
0.
class. Don't worry, but just very quickly. What's the acceleration when you're not moving?
Zero.
Nope. Do you all agree with me that we all are experiencing gravity? You can't escape it without leaving the bounds of Earth. Yes?
Yeah.
We are all accelerating down, and that's why we feel weight. The floor is pushing back up against us. Thankfully, the floor is able to do that, so we don't go crashing through the floor. You guys with me? When I throw this pen up in the air, I don't know if I want to because I only have one eye that really works. But when I throw this pen up in the air and it gets to right here, the velocity is what?
0.
But the acceleration,
It's gonna go negative.
negative 9.8 meters per second squared, it's still there. So your velocity can be 0, but that doesn't mean your acceleration is 0. You could be
Moving with that move.
turning. Yes. Okay. Stay with me.
So with the
So that's why the question says the acceleration when the particle's not moving. All right. When the particle's not moving, what formula does that relate to?
C equals to 0.
So what equal to 0? The velocity. Good. So if we just set the velocity equal to 0, I can figure out what time this problem is talking about, right? When the particle is not moving, I want to get time. And once I know what time that is, I can put it into the acceleration formula. And neither answer you get is going to be 0.
One.
Say.
1 minus.
Huh? No, t equals 1.
That's one answer.
And the other one is t equals 0.
Yes. And I forgot, I think on the key I used 0, but look at my domain for this problem. What's true about the domain for my problem?
0 to 1.5. So it has to be.
But do I include 0?
No.
No. All right. So the answer to this algebraically is 0 and 1. I mean, you factor this thing, yes? But I could throw this one out. So what's the next level of this problem? It's a 2-step problem.
Plug in that time.
Plug 1 into acceleration, yes. And you get
0.
No.
18 minus 36,
Negative
negative
18.
negative 18. What?
Meters per second.
Meters per second squared. It's meters per second per second. There aren't like little Picasso time units. Little square seconds going somewhere. Okay. But you guys see how you just have to slow your roll. Don't start throwing 0 into places. Just go, okay. Find the acceleration. Okay, we don't know the acceleration. When the particle's not, what does it mean when something's not moving? It means its speed is 0. Okay. How do I do part D? How do I find the maximum area, for example?
M plus L that.
Well, how do I find the maximum area? I have to first make what kind of a formula? How do I find the maximum area? To find a area formula, and then what do I do to that formula to find a maximum? Take the derivative, your critical numbers, you with me? This always trips students up. What? It's not area I want to maximize here, is it? It's velocity, but I don't care what the blank is. Maximum blank. I find the formula for blank, and I take its derivative, and I find critical numbers. So how do I find the maximum velocity?
Take the derivative of.
Did we already do that?
Yes.
Yeah, the acceleration is the derivative. So I set this equal to 0,
And then.
get my critical number. Yeah, okay.
2.
1/2.
Oh.
Yeah,
Close.
So close, but so far away. And then you throw that into velocity, If you take one more derivative, I don't think I did this on the answer key, but what's one more derivative of this?
Negative 36.
Negative 36. Did I tell you what the name of that is?
No.
We have position, the derivative is velocity, the derivative is acceleration, and my first car was a 1984 Dodge Charger, and this was a real-life application of the third derivative. The third derivative is literally called the jerk. If your acceleration is not constant, it's like that, and that's exactly what my car would stall while I'm driving. So I put it in neutral, start it back up. Put it, when this guy was raking his yard, he's like, he's starting his car right now. Oh, shit. Anyway, sorry. Major side notes, I'm very sorry. Do you need to know the third derivative is called the jerk? No. But if I took the third derivative, I get a negative, which does tell me I found a maximum. Yes? Okay. So again, if you see the word maximum, minimum, least, greatest, you know it's an optimization problem. How do you do any optimization problem? Your first step, ask me, all that shit is just to create a function for the thing you're trying to optimize. You need to take its derivative, find the correct numbers.
8, please.
Oh yeah. So what's the first level thing to do with these kind of problems?
Plug in a 3 to see if it's
Yeah, plug in a 3. What happens when you plug in a 3?
Probably get 0 or 0.
Don't assume.
For which
You get 0.
Never make an assumption, because then you make an ass out of you and umption.
Good.
What do you get when you plug a 3 in?
For which one?
First.
You get 0 over 0.
No, you don't.
You get 3 over 3.
Yeah. All right. Good. So see, right there, I want you to catch your brain right now, and I want you to realize, don't let that shit happen. Don't assume. Go. Oh, I know where this is going. No, you don't. That's why the first thing you do is plug it in, because you know I might give you a problem where if you just plug it in, you're done. Have I done that before?
Yeah.
Yes, of course I have, because it's trying to show you, don't start doing shit. Plug it in first. So is this one where I have to do conjugate or something?
No.
This is not indeterminate, right? Which means I should be able to determine the answer. So what's the next level? What does 3 over 0 mean?
And
My answer is going to be some kind of,
infinity.
now what's the next thing I got to consider?
What is a positive or
Is it
negative?
positive or negative? And what kind of numbers do you get when you're throwing in stuff bigger than 3? The top is, of course, close to 3. That's positive. And the bottom is like square root of 0.1, square root of 0.01. Those are all positive. In fact, radicals could only have positive outputs. So what kind of infinity is the answer? Yeah, positive infinity. So again, do you get non-zero divided by 0? You know your answer is going to be some kind of infinity. And then you just go to yourself, as I get close to this number, am I getting positive answers or am I getting negative answers? And that's going to be what kind of infinity. That's why it's not an indeterminate form, number over 0, because I can determine the answer. Now what happens in part B? There I get 0 over 0, yes? And if you need to, you can, if you forgot what cotangent of 0 is, it's cosine of 0 over sine of 0. Actually, what do you get then? Did I set this up right? No, okay, I'm being stuck. Pi is being stuck in there. It's cosine of pi over 2 over sine of pi over 2. It's 0 over 1 is 0. Kind of worried about myself for a second. Somebody with me? So you do get 0 over 0. What does that? What does that mean? I could use medical dude. Yes. Not old Greek dude. Medical dude. Derivative of the top. What do you have to be careful about when you take the derivative of the top?
Negative.
Yeah, there's a chain rule in there. Because the inside's more than just x,
We
correct?
actually do.
Sure. What's the derivative of cotangent stuff?
Negative cosine.
Negative.
This goes to 0 over 0. What is it again? Sorry?
Negative cotangent.
No.
Oh, negative.
What's the derivative of tangent?
Secant.
Secant squared. So what's the derivative of cotangent?
Negative.
Negative cosecant squared. There's a beautiful analogy. Co stuff is negative. Tangent secant squared, so cotangent goes to cosecant squared. It's just negative because it's a co-dude. Negative cosecant squared. x over 2 times derivative of the inside, 1/2. All over, what's the derivative of x squared? What's the derivative of pi squared? Good. Okay. What do you do now? Do you do another derivative?
You multiply the one.
You don't even know if you can use that because you don't even know if it's indeterminate. So yeah, you plug it in. What do you get when you plug a pi in now? Does anyone know what the cosecant of pi over 2 is? What's the sine of pi over 2?
0.
No, 1. So cosecant of pi over 2 is 1 squared is 1. Negative 1 times 1/2 over 2 times pi. Hey! Simplify that, you're done. I didn't get an indeterminate form, so it's determinate. Even better, the bottom is freaking finite. It's not finite, but not 0, so that's beautiful.
Yeah, for example, like 8C, you could use the L'Hopital's rule, but how do you know which one goes on top?
On 8C, is 8B okay?
Yeah.
8C, what's up with 8C?
It goes to 0.
What does it go to?
0.
This goes to,
0.
this goes to.
0.
No,
Oh,
1.
ln 0.
If it went to 0, I'd be done.
Goes-
The answer would be 0. 0 times 0 is 0.
Goes to 1.
What does this go to? As x goes to 8?
Natural log of 0.
What happens to the natural log as its input approaches 0? Yes. Now, real quick, 0 times anything is,
0.
yeah, we just all lied, but it's okay. What's anything times infinity?
Infinity.
So what's 0 times negative infinity?
Negative.
We know. What did we say? 0 times anything is?
0.
Oh shit! Anything times infinity is?
Infinity.
Infinity. So what's 0 times negative infinity?
Indeterminate.
We don't know. It's indeterminate. It depends on who's going to its thing quicker.
So the answer to
Why
this-
can't I use L'Hopital's rule though?
It's not a fraction.
Not a ratio, not a fraction. Exactly. It's hardwired to work for just things that are ratios.
But on the
So your question is very good. What do I flip? Well, I flipped the simpler function, of course. I could flip either function I want to, but do you want to take the derivative of 1 over natural log of something? I mean, you could. I wouldn't want to. I don't know if you guys are with me or not. Do you guys, anybody remember what to do here so I can use L'Hopital's?
I'll put it over 1.
So I'll just rewrite this as, leave the natural log up here, but if I flip him, I gotta flip him. Is that a ratio?
Yeah.
What does the bottom go to now?
0.
No. The bottom,
1 over 0.
which
No,
goes
seven.
to infinity, and the top goes to infinity. It's negative, who cares? And that is indeterminate still, of course, but it's a ratio now, so now I can use L'Hopital's. Yes. There's a problem just like this on the test. Quiz. One of those things.
I have a dumb question.
Great.
Wouldn't natural log, right?
What are you trying to do?
I didn't know. I got this one. There's no number 10. Like it goes up to letter 9.
That's why I should wait. What's up?
If you plug in 8, right, you're gonna get
Where we
8
at? Sorry?
Here. Or just the top, just the beginning.
Sure.
No, all the way on the top.
Oh, here.
Yeah.
Yes.
If you plug in 8, it's gonna be 8 minus 8. You're gonna get 0 for that.
So true.
And then for the natural log, you plug in 8. You're gonna
Yes.
get 8 minus 8, which is natural log of 0.
Yes. So true.
Isn't that 1?
Hell no. Natural log of 1 is 0.
What's natural log of 0?
There's an asymptote there.
Oh,
So,
yeah.
so real quick,
yeah.
natural log of 0 would be the number you raise e to get 0. What number can you raise something to get 0? No such number exists. That's why there's an asymptote there. Okay. Maybe tomorrow I'll wear my little do dancing function shirt, because knowing what functions look like saves you from so many little things. It's crazy. Now, any of these that we go over, we don't have to just stick with the practice. If anybody's like, can you do another one like that? Can you do another one like that? Can you do one like this? Right? Whatever the shit you guys want to look at. Today's the day, man. Tomorrow's everything. So I want today to go over everything. Yes.
Dumb question. For V, why is x over 2 greater than 1?
Why is
The x
x over 2 derivative? Why is that?
Oh, what's the derivative? Well, what is x over 2? What's half of 7? 7 over 2, right? So half of x is x over 2. So x over 2 is half x. So the derivative of x over 2 is the derivative of 1 half x, this is 1 half. Yeah, good. Okay. This is the thing when you first learn lines and you have like y equals x over 3 plus 2 and people freak out. And I'm like, no, you just pull the 1/3 out front so that you can see the slope. X over 3 is the same as 1/3 x. Right. Yes.
Is there anything in multi-term that, other than the extra credit, is there anything in multi-term?
Yes. Sorry, I'm not gonna tell you. Sorry. There will obviously be. How long do we have for the final? I'm gonna give you probably a little bit more time than normal, right? But I'm not gonna design a final that will actually take 3 hours. There's no way I'm gonna do that to any of us. I will give you more time than I normally do. You with me? But I'm not gonna design a test that takes that much longer. So, am I gonna have to let go of some stuff? Yes. And I understand a lot of you guys are like, just that's what that is. I haven't finished making the final, I'm not sure. And I wouldn't tell you anyway. So what could be on the final? Everything that we've talked about this semester, that's all. That's all. I'm really sorry I'm being evil, but that's what the final's supposed to be.
Can you not put discs on
Which one?
the final?
Which part?
No, you just don't put discs, washers.
Oh, discs and washers? Okay, extra. You want extra? That's what I heard you say. Okay, extra discs and washers. I got you.
Number 9D.
9D. Are you guys, listen. One thing, really quickly, just go with me for a second. As a teacher, one thing I've been really getting more interested in is how to highlight to a student the feeling of understanding something. I always thought if a student can catch themselves understanding something, they'll realize, oh, I can understand something, and then that kind of opens doors for later. Does anyone look at that and kind of, not immediately, but pretty quickly tell what kind of problem that is? Use of, yes? Now, if you really pay attention to what just happened in your brain, how much did you have to stop and analyze each piece? And how much was sort of just realization as you looked at the whole problem? I mean, there are visual cues. It's loaded with shit. Not every problem that's loaded with shit would be a use of, but that's a really big green flag for a use of problem, yes?
So with
You also see what else tells you it's use of?
The y is 1 less.
Yes. And there's an interesting thing that happened on the test. If that was y4, y to the 4th, and that was y cubed, you couldn't do it. You could not do it. This would be out of our reach. You could do it after the first section in Calc 2. We couldn't do it right now. The du piece has to be free because I have to be able to put it with this guy, yes? So the y to the 4th has to be somewhere potentially stuck. The y cubed has to be free because it has to go with the dy. Is everybody with me? So don't just go 1 times less. No, go, oh, the lesser power is free. U sub is probably going to work. Sorry.
So, for use of to work, the lesser power has to be free. With the power that's 1 more, it also could be free and would still work.
Could be free, yeah, of course. Yeah. So 97% of the time, U is what's stuck. 100% of the time, U is the thing whose derivative is in there also. Yes. So what would I let U equal here?
Y to the 4th.
Even better,
1/5 y.
1/5 y to the 4th, because that doesn't cost you anything, and it actually makes the resultant thing e to the u. Do you guys see that? There's real quick. Nobody had to try this, but there was a bonus problem I want to show you real quick. Let me see, can I show you? No, this is really old. Here we go. Oh wait, this person here, yes, there. I gotta catch up with people that just got here. Let me do that first real quick. It was bonus number, I think it was the last bonus. No, it was number 4. Bonus number 4. Wait, let me see here.
You fun?
You're not worried?
Nah, you're fine. To be honest with you,
There we go. That's it. Real quick. I know this was a bonus, but what was it again? Shoot. It was, oh shit. Do I have a copy of that? Oh, here we go. It was x minus 4 cubed plus 7 squared. Real quick, I know this was bonus. Hold on, let me zoom the hell out. This is crazy. I know this is bonus. I could have very easily made this just not bonus, just a normal problem. All day long I could have done that. One person, well, okay, I didn't mean to say it like that. One person, not mistakenly really, but said, okay, let me let u equal this. Because then du is 3x minus 4 squared, and x minus 4 squared is this. Do you guys see that? That's not bad, but they could have been nicer to themselves. Because their resultant integral will have like u plus 7 squared, which is worse than it has to be. So what could you let u equal?
Plus 7.
Plus 7, because look, that doesn't change worth shit, yes? So you kind of want to let u equal the most that doesn't change what du is, because then you're covering for more parts of the problem. I don't know if that makes any sense though. Do you see that distinction? Maybe. Okay.
wait, but what I did was I factored out the x-ray minus 8.
What do you mean factored it out? Oh, you factored it to be x minus 4 squared? Yeah, and that just matches with this, so there's your dx as long as you put it 1/3 here, right? Then that whole part on the top is du, and then 1 over u squared, so you get out of here. Anyway, I'm not going to do the whole thing for you, but yeah. The only point I wanted to make there was, if you don't include the plus 7, your du is the same, it just makes your integral a little worse than it had to be. So let u equal blah, blah, blah plus a constant, because then you cover more, and the du stays the same. Maybe. If what I just said makes no sense, it's okay. It's not immediately
No, I
necessary.
got that one wrong. I didn't add the plus 7, I got confused.
I had it, but I still didn't.
Damn it! Alright.
This one mine?
Now again, if you guys have questions from the test, I'll create problems that are like those, right?
Oh, you put the
That's acceptable. Acceptable to ask questions from the test, that's fine. Yeah.
Bro, I don't know what the hell I was doing.
From the practice fund?
Did you get any points from the bonus? I only got this one.
So guys, if I give you a problem like this, there's very little information there that I'm giving you, because you have to figure something out yourself. That's the first level thing you need to figure out. When I say bounded by the curves,
Inscribed?
there's no inscription going on here. There's no inscribing.
Like it's between.
You integrate the x minus
I don't integrate anything yet,
the top.
because
is-
there's a whole bunch of things I don't know. When am I going to let the integral go from
No,
to?
you set them equal to each other, no?
Yes, I gotta figure out where the kind of region starts and stops. So if I want the region these two curves capture, what kind of functions are these two? I don't know why I made them both x, but maybe you should know that.
Parabolas.
Parabolas?
Yeah, so one parabola is up and the other parabola is down. Do you agree with me that as long as this one goes down enough, this was up enough, they're capturing something, yes? Where does that region start and stop? Well, I gotta know when these two intersect, because that's the definition of where the region that they catch starts. Does that make sense? So if I just say find the area bounded by these curves, the very first thing you should do is set them equal to each other.
0 and 8.
I can't remember. No, it doesn't sound right. Hold on. You
Or
get,
0 and 4.
that sounds more right. Yeah, you get 2x squared minus 8x. You get 2x, yeah, you get x and 4. I mean 0 and 4. Now listen, this is what's hilarious to me. If I want to graph these, I know that is an up parabola, and I know that's a down parabola, right? And I know they meet at 0 and 4. So what do I get when I plug a 0 in to either one of them?
0,
Okay. What do I get when I plug a 4 into either one of them?
4.
Yeah, 16 minus 12, 4. So this is where they meet. Those two places are where they meet. How do I tell which one's on top? Well, that's kind of a silly question
The one that
because
doesn't- the one that's not negative, so it'd be.
no, this one's on the bottom actually. So here's another way you can do it. Just plug a 2 in. So both of them. What do I get when I plug a 2 into this guy? 4 minus 6, yes?
Negative 2.
Negative 2. So
Well-
this guy looks like him.
Well, wouldn't you just be able to tell visually?
Well, normally the one that opens down is going to be on top because he bulges up, yes? Okay. And then when I plug a 2 into him, I get 10 minus 4 is 6. So there's his vertex, sort of. Not really vertex, but we'll be all right. So there's the region that I caught. I can't remember if I drew it on the because all I need to know, I didn't ask for a sketch. All I need to know is which one is on top. And the minute you know where they meet 0 and 4, bless you, if you pick any point in the middle, if they meet at 0 and 4, could they possibly, the one on top, switch with the one on the bottom before it gets to 4? If the only places they meet are 0 and 4, could one be on top for a little bit and then the other one is on top?
Yeah.
Because then they would do what again?
Flip.
They would meet up again, but we found they only meet at 0 and 4. So does everyone agree? Between 0 and 4, one function's always up here and the other function's always underneath.
Mm-hmm.
And then I just pick a number in between 0 and 4. I pick 2, you can pick 1, I don't care. When you put a number in, whatever's bigger, that one's on top. And the other one's on the bottom. So then how do I set up the integral? How do I find the area between them? I don't even need the picture for this problem. How would I integrate? From what to what?
From 0 to 4.
0 to 4. What function do I put first?
The one on the bottom. Top. No.
You integrate the top.
If I want to have a
bottom.
positive area, do I want the bigger one first or the smaller one first?
The bigger
The
one.
bigger one, which means in this case the one that goes up more than the other because it's higher outputs. Which one's that? Is it F or F? No, is it x squared minus or 5x minus that?
The one with the positive one.
Is it 5x minus 6?
Yes, because the down parabola is up top, yes? So you put that first, minus the other dude. Don't make the mistake of not of forgetting to distribute the negative there. And then you just have an integral of a polynomial. That's the easiest thing I can do. Right, get your nice terms together. I really didn't, well, all right. I'm very happy. I got the test graded. I got your grade sheets done. I got your corrections graded. Holy shit. If I would have had a little more time, I might have made like because sometimes what I'll do on practice finals is I'll have the first part of class will be like group worksheet, and then the second part will be individual questions. I always want to make sure I leave room for any specific things people have trouble with. I didn't have that kind of time. But if there was any that we just want to work on as a group, maybe you guys work on some stuff and then I'll come in and show you the steps. We could do that. It could be from the practice final, homework, quizzes, whatever. It's up to you guys.
Can we do the absolute extra math?
Yeah. If you haven't done, where was it?
Right there.
Here. If you haven't done number 4 yet, go ahead and try out number 4. If you have tried out number 4, just sit there for a bit. work with other people if you want to. It's okay. Oh, Peter. Oh, you need this?
Yeah, you find the critical number.
You find the derivative. So what? 1 times e to the negative x plus x e to the negative x squared times negative 2x, right? There's this product rule.
Oh, okay, okay, because you took the derivative of x times the, okay, yeah.
So, and then, and what do you do?
By the way, just so you know, if I gave you probably number 5, I would also give you the volume formula. You don't have to
Negative
memorize
2x e to the negative
cone
x squared.
volume.
Factor. What do they both have in common?
An e negative x squared.
Yeah. So we factor that out, make it equal to 0.
You have to after.
Oh, is that it?
And so,
That was so. You also gonna plug in like your plan. So it's like
Okay. Yeah, right. Okay, you're not gonna get to
no.
yeah, we will do everything.
You said it equals 0, and then you got red 2 over 2. How did you get red 2 over 2?
Where are we at?
For the 0, for the x, how'd you get rid of?
We'll get there. I forgot you stole one of those.
Sorry.
Oh, get over it. Already did.
But by the way, you made a mistake on 2A.
Hell yeah.
I mean, you're doing intangible?
Where are we at?
2A.
Yeah.
Because it's,
Yeah, you're gonna get
it says 3 ln x plus ln parentheses x minus 1. The
Yeah.
actual thing is 3 ln x squared minus x.
Factor in x out.
Factor in x out with the
Yep.
other?
No, factor in x out inside. You get x times x minus 1. The natural log of the product
Oh,
of
that's
two
how
things
you
is the
did
sum
it.
of the natural log.
And then you distribute the ln.
No, you don't distribute ln. It's just ln of a times b equals ln a plus ln b. That's where I get the plus. Right? It's not distribution, it's just log properties. Is everybody cool with this here? You guys get this? Like this is derivative of x is easy times the other dude plus leave x alone. Derivative of this guy's chain rule. It's himself times derivative of the inside. And then if I clean this up a little bit. Now, what do I do with all that business? Why did we do that? Why did I take a derivative?
Factor out and make them e.
Why did I take a derivative?
So
I didn't take a derivative in order I could factor something.
So I can take the x or find the x.
Find the critical numbers. Good. Because I can find x. See, it's right there. How do I find the critical numbers? I take this and I set equals 0. And that's why I factor. Good. So what comes out of both?
E to the negative x squared.
So you get 1 minus 2x squared. Now I jumped to the answer because I was creating this answer key this morning. Because I almost forgot about it. Can e to anything ever be 0? The way I asked that, you know the answer is no, but if you're not sure, that's true. You can't raise something to a power and make it 0. And then if I solve this, I add 2x squared over, divide by 2, take a square root. I get square root of 1/2, which is square root of 1 over 2, which is square root of 2 over 2, plus or minus.
Oh, because you can't have a rank on the bottom.
Now, rad 2 divided by 2 is about 0.7. So is positive rad 2 divided by 2 in the interval? Is positive rad 2 over 2, considering that rad 2 divided by 2 is 0.7, is positive rad 2 over 2 in the interval? No. Is negative rad 2 over 2 in the interval?
Yeah.
Yes, because it's negative 0.7. It's in there.
So you divide by 2 on both sides.
So remember, absolute extreme, you're just trying to find the candidates for the
Because
contest.
it's plus or minus.
The endpoints always get in. They're the son and daughter of the owner. And then you look for the critical numbers in the middle. Those are the ones that earn their way in. So what do I do now?
Because from our.
Yeah, both sides.
Plug in -1,
Yeah.
plug in 0.5, plug in negative rad 2 over 2. Plug them in where?
The
The
original.
original function, k-caps. Plug them here, and then you just step back and you see who's biggest, who's smallest. God, I'm really excited to see what 6 a.m. Jeff would did with this. Okay. I don't remember who was from. Let's see.
We plug in right 2 over 2 into the axis.
You plug in -1, you plug in 0.5, because those are always part of the contest.
And you also
yeah.
plug
The
in
endpoints are where the max or the absolute maximum could happen. And then you also plug in the critical numbers because that are in this interval, because it's another place you can
and
obtain
you
that.
pick the absolute value and
You
absolute
plug it
value.
into the original function.
Because now I want to know
The point.
the outputs, which outputs are biggest and smallest. I don't care about the slope. Yeah.
The only thing
Yeah, we don't. We only have what, 8 originally? So like,
Are you recording that?
Yes.
Yeah, she didn't forget that.
Yeah, you plug in -1 0.5 and then negative rad 2 over 2 and see rad 2 over 2 is in like 3.7.
So here we go. Look. Let's do this. I would suggest, I want to talk about number 10 for a moment. And then maybe, does anyone want to look at number 12? Or number 13 is the revolution stuff, the rotations. So let me talk about number 10 for a second. Do you see why I put number 10 by himself? Poor little dude. There's got to be something trippy here, yes? Because I have an interval section, so why the shit did I put him all by himself? All by himself. Okay.
Which one?
Can anyone see anything about that interval that's off?
The keys.
There's no.
It's 2.
It's 2.
Look at the function itself. Does the function have an issue somewhere? Just look at the function inside. T squared over t plus 1. What
There's 2 variables.
Oh, that
is that function cool everywhere?
No.
No, you're thinking too much. Just the function t squared over t plus 1. Where does he freak out?
At 0.
No, he's cool as 0. 0
At
is
1.
0.
At -1.
At -1, yes?
Yeah.
Now, what is the integral
-2.
defined over? What is the interval for the interval?
-2.
Does it include a place where my function freaks out?
Yes.
Okay, good. So therefore, I can't do this.
Wow.
In Calc 2, you will discover that some of these types of integrals you can do. But for right now, for us in Calc 1, the function has to be continuous on this. And it is discontinuous at -1. In fact, it's not just discontinuous, it's infinitely discontinuous. And that is not something we can handle in Calc 1. So according to what we know, the answer to this is can't do it.
So technically, on the test, if you were just to put nothing,
You would just put can't do it. If you leave it blank, I'm going to think you didn't know what to do. So don't leave it blank.
Oh, okay, because -1 is between those 5 and the rest. So when you put
Hmm?
-1. Now I'm thinking to myself, because negative 1 is between 5 and negative 2, so when you plug in negative 1, it becomes
So
divided by 0,
somewhere
which is
in the
undefined.
interval, the function is undefined.
Yeah, which means you can't do the whole
We
thing.
can't do the interval.
Okay.
Now in Calc 2, section 7-8, you'll do a limit as t goes to negative 1. You'll explore the interval. Some of those actually work. We don't know this shit yet. So for us, it's all right. Yes. Here, can everybody work on number 5? Here's the volume formula for a cone.
Huh? Just
This is actually the volume formula for any pyramid. A cone is the simplest pyramid. I'll stop there. You don't have to know all that. I'm sorry. It's just so cool. The volume of any pyramid is 1/3 the area of the base times the height. And how do I make a cone? I start with a cylinder and I cut the cone out. And what's a pyramid do? It's one point that goes to the corners, and then a circle sort of has infinite corners. I'm sorry, I'll stop. Just try number 5 out. I highly recommend drawing a picture.
Why do you have a yellow paper?
because I ran out of lens. So I'm having to use them.
That's what you use to find them.
No, I'll just put other things.
I was saying, like the competition they give you half the points off, but like any shit. Like, you got it right.
Radius is 3. Height is 10.
So it would be height over radius equals 10 over 3. And we pass me pretty much.
Why? What do you mean?
We're trying to find
How fast the water is rising?
right? So, right, the formula is volume equals 1/3 pi over squared times height, right? So we need to find the radius.
Radius is 3. Oh, at 5.
Okay. So we need to go height.
If you get to a certain point and you want me to make sure you're on the right track, just let me know.
Height over radius equals
If you're
10.
completely stuck, just let me know.
Oh.
What's your name?
You get it?
It's kind of like.
And then we
If you don't want to let me know, let me know.
58. Now that, which means that this would be our R, that'd be our radius. Now we plug this in into the actual formula. So volume equals 1/3 10 over 3 squared. 10 over 3 h squared. 10 over 3 h squared. Oh, sorry, 38 over 10 squared, sorry.
Oops, you didn't put an R there.
Over 10.
Yeah. Squared
The entire function.
and h. 21. Wait, sorry, no, you didn't put the h, I'm tripping. Yeah, I was gonna say, yeah. So now we just volume equal 3 pi.
Draw the codes, maybe it'd be nicer.
Yeah, because we multiply.
So everybody got like that much drawn right there.
Then,
If you can't draw a cone, just make a triangle like you just look at it from the side. Doesn't matter.
and we find the.
What do I do here? Always draw in your water. How tall is the water?
5.
How tall is the water? H. Sure. And of course, what's the radius of the water? Now, this is the thing that I kind of focused on for a bit before we even fully got into this section. Was this idea, yes? What's the idea here?
Two triangles?
Similar triangles, yes. So that I can set up what?
I don't know.
It's like two and seven.
You tell me good.
Oh, really?
I want you to go, so like, it's your job, man.
You tell me.
Did anyone tell you what you're doing here, Jeff? Okay. You can set up a proportion, yes. And there's a ton of different ways you can set this proportion up. You could go like radius small to radius big equals height small to height big. You can go radius to height of the small is equal to radius to height of the big. All that shit mathematically comes out to the same place. So I don't have a clue how you guys want to do it. If I do radius to radius equals height to height.
You should do height to radius.
No. Looking forward in the so this is what they tell me. Now this isn't really a tell me ask me problem, but just to show you could actually look at some of the related rates as tell me ask me. Looking ahead a little bit, which variable do I actually want to keep alive?
H.
Yeah, I want to keep H alive. Rising is dH dt. 5 centimeters deep is the height at a certain point, yes? So what letter do I solve for then?
The radius.
The radius. Good. And some students always trip out about that. Of course I want to solve for R, so then I plug it in and R disappears. It's a very invasion of the body snatchers thing. I go in the middle of the night, I take R and I replace him with something else. Yes?
So we cross multiply, so 10R.
Or just multiply the 3 up so you can get there quicker. Now I got my volume formula, and of course the whole problem with this formula is there's too damn many letters, but now I can just,
Replace. Plug in.
yeah, middle of the night, replace that. And then just simplify that down. And then I've got a relationship between volume and height. Now the thing I skipped here, which is bad, but I'll be all right. In symbols, what is this?
DV.
dV/dt. And in symbols, what's the question? dH/dt. And of course, what's this guy all about?
H.
He's the snapshot that you don't worry about until the end. So if did anyone get to this point?
Yeah.
Did you simplify it?
I don't know
Huh?
how. I don't know.
Here's how you do it. You ready? Here's how you do it. You just do it. What's 3h squared? What's 3 squared? That's crazy. What's h squared? H squared. What's 10 squared?
100.
Shit, now I'm wondering if I might have left that as 10. Oh well, too bad for me. And then 1/3 of 9 is 3, so I get 3 pi h squared times h is h cubed over 100. Yeah, I'm pretty sure I did leave it as a 10. I did. Oh, that's what is that? Well, it's part of it. Still averaging about a 97. Yeah. And now, I have a related, I have my volume and my h are related. But of course, I need a relationship between my rates of change. So then what do I do with this?
You plug it back into the.
No.
Take the derivative.
I know dv dt, I want to figure out what dh dt is.
I took derivative.
So I take derivative. So then I have places to put stuff in for, yes? So I'll do this side. What's the derivative here?
9.
Yeah, the 3 comes down.
9 h squared.
Times?
Doesn't the 5 go to 0?
Of course not. Why didn't the 3 go to 0? I'm not doing a product rule because if I did a derivative of this would be 0, derivative of this would be 0, so I only do the derivative of this and these guys stay. Constants always come for the ride. Yes?
So 9 pi.
3 comes down, makes it 9 pi, it's h squared over 100 times dh dt. Good. And then I throw 2 in here. And now you solve for dh dt.
Why didn't you do anything to the 100?
I didn't have to. All right, guys, look. What's the derivative of 7x?
7.
Why didn't you do anything to the 7? What's the derivative of 11x over 271?
11
Nope.
over, no, 11 over 271.
11 over 271. Why didn't you do anything to the 271?
I didn't want to.
Me either. Thankfully, I didn't have to.
Wait, so then you would divide by 9H?
Well, no, you multiply by, yeah, multiply by 100, divide by
So you
9
multiply
by. What else could I plug in there? I forgot. What else do I know, thankfully? What else do I know?
The height.
Height is 5, yes. Okay. So now you just divide, you multiply by the reciprocal and you throw it in the calculator and you get a number. On the answer key, I think I left this as a 10, which I am cool with. But it's supposed to be 100. But very quickly, do you guys see how to categorize this as a related rates problem? What was the key part of this that told me it was related rates?
But I hated it.
Huh?
But I hated it.
Oh, Roman does a vibe check.
Now that
What is it about number 5? I actually have it circled.
It tells you the rates.
Yeah. It asked me about a rate of change of something, and it tells me about the rate of change of something. It's probably a related rates problem. Yes.
Wait. Did that ever come to use?
Did what now?
The rate of the water.
Do it again.
Did that ever come to use?
Which part?
The 2 centimeters. The one you have circled. No. Oh.
That's the rate of change of the volume, yeah? Okay.
That should come out to like 2 divided by 2.25 pi.
It'll be 2 over,
2.25.
it'll be 8 over 9 pi. 25 over 100 is 1/4. 4 times 2 is 8, divided by 9 pi. So it'll be roughly
Why don't you just do it?
0.3 something. It's probably 0.2 something, isn't it? Yeah, it's like 0.28. Yeah, it's 10 times what I got, because I left the poor little dudes in town. Does anyone have a candidate? Any questions from this problem before we move past it? And just to tell you, here's a question you could ask me right now. Hey, Jeff, could we do another one of those? Yeah? Okay, there. I don't know. That's the only one I brought. Let's see if we can steal one. No. What about number 14 here? No, Jeff. Wrong button. If a snowball melts and nobody's around to see it. No. If a snowball melts, will the tree still fall over?
Related rate.
Yeah. It totally is.
Section 3.9.
Alright, so let me capture some of this stuff. Now this is a problem where I would give you the surface area formula for a sphere, but does anyone happen to remember it? Let me capture some stuff here.
Something equal to area.
Yeah, so the change, I'm gonna call the surface area just S. So the change in surface area is 1 centimeter squared, and it's decreasing because the poor little dude is melting. Somehow he's melting but staying perfectly spherical. We'll be cool with that. Find the rate at which, and the question is, what's d dt? Where d is diameter. dd. The surface area of a sphere is 4 pi r squared. Now, can anyone immediately identify an issue that I need to rectify based on something they told me or asked me or something?
Yeah, the question they have is how fast is the diameter changing? My formula has radius in
Just
it.
multiply by 2. Right?
Nope. How do I force a diameter to show up? Diameter is what related to radius?
2 times R.
So what's R?
1 half. Oh no, D over 2.
Sure, 1/2 d or d over 2, so I can plug that in. So the surface area of a sphere is 4 pi times d over 2 squared, which is pi d squared. Now if you look at that, that's a much better way to write things, but at some point in history we decided everything's got to depend on R. But why is that such a cool formula? The area of a circle is pi r squared.
What did the 4 go?
Huh? You tell me, where'd the 4 go?
Divide by 2.
2 squared is 4, cancels with 4. Yeah. So let's go back. It told me how much the surface area is changing, and it wants to know how much the diameter is changing. Can I do that now?
Yeah.
What do I do?
Derivative?
Yeah. So it'll be ds dt equals
2 pi?
2 pi d times,
Times S
2.
ds dt.
no, that's over here. What am I taking the derivative of? The diameter. So it'll be the derivative of the diameter.
And you plug in what we have for D?
Do we have d? Did they tell us what the diameter is?
Yeah, did they say it was
When the diameter's
10 centimeters?
Yep, cool.
So 2 pi I times
Yeah, 2 pi times 10. They told us what the surface area was doing, and now I can solve for what the diameter is
10. So
doing.
it'd be 20 pi, so it'd be negative 1/2 over 20 pi.
Negative 1 over 20 pi.
20 pi? I say negative 1/2, what the fuck?
No, negative 1/2.
Times
With a pi and a 10 down there too.
Just that's not so different. We got one shot. Hey, really, wait, 50.
Sorry?
50 or 50.
I mean, we could. Do you guys want to? Here, let's do this. I was thinking about doing this. Would anybody be interested in number one, like a break, official break? But I can go grab my thumb drive, and if you want to, you can double check, put eyes on what I have in the spreadsheet, or you can show me if there's a mistake. Does anyone double check their grade sheets? Did anyone have any errors on there? Was I saying I was missing homework I shouldn't be? Did you guys even check?
Yeah, I have a question.
I don't know. If I were you, that's the first thing I would do. Huh?
Once we take break, can I check if it's still possible for MA?
Yeah, let's do this. Let's take like you want a 15-minute break? Sure. 5, 10. So come back at 10 till, right? 5, I don't know numbers. I've never been good with numbers.
Yeah.
And then in the interim, if you have anything specific, just let me know.
If you've never been doing it, what the fuck are we doing?
It's like on the first day I like to pass the syllabi out, when I don't give enough out to a row, I'll go, I'm not good with
You know,
numbers.
it's like
They all
Einstein.
look at me like,
It's like Einstein saying I've never been good at physics. What the fuck are we doing? If you're not good at physics, what the hell are you?
he just made everything up, and we didn't know enough to say.
I don't know what he's talking about, but it's crazy. I agree.
Now, would all of those considerations happen in that same order? No, but those are all the kind of considerations you have to consider. Did you consider the considerations? Okay, so what's the next thing I want to do? In fact, this could be the first thing. I don't have to do anything I just did. What's kind of like the very first thing I need to do?
Fine, well, we know one of them is 1, Jared.
What do you mean? Sorry?
Because if it's giving, oh, wait, no, wait, is that just where it's, I think I was thinking.
Okay. So you have to find where the two functions cross, right? This is what defines my region. Now there's two ways to think about this. If you solve this for x, you could just set each of the x things equal to each other, yes? Or look at this, x equals this. If you just take this and plug it in, you'll actually end up with the exact same formula you would get if you did it the other way. So like I would make 1 plus y squared equal y plus 3. Or this would be y equals 1 plus y squared minus 3, and then I just go from there. Both ways give me to the same place. Oh. So let's see, we got. Is everybody cool with that so far? And then of course I do what with this? Okay, so now I know that they cross at y equals -1 and y equals 2. So if I want to give myself a little sketch, and you know I'm going to ask you to make a sketch on the actual test. Y equals -1, y equals 2. That's where they meet. When y equals -1, what's x? Did I do this right? Let me see.
2.
Yeah, when y is negative, oh, I see, I'm looking at this backwards, Jeff. Let me solve this one for y. That's better. Yeah, when y is -1, either one you plug it into, you get 2. So -1, so 2, -1, they meet there. And when y is 2, if I plug it into either one, I get 5. So 2, 5, they meet there. Did I? This morning is a haze. Which one was this again? This is the last problem, right? Number 8. Did I do this right at all? Why am I doing it right now? That's a good question. Let me see. Yeah, oh, okay, this is fine. I think it's fine. So when y is -1, x is 2. When y is, oh, I see, I put this in the wrong place. When y is 2, that's what I just did the wrong thing. When y is 2, so what I should do for myself is build these points out. When y is -1, x is 2. When y is 2, x is 5. There we go. That's better. Now here's the trick. I already know, I've basically plotted 4 points in a way. Because both of these points are points on both graphs. So one is a straight line. I don't have to do shit for that. There's one of them. I don't have to think about it. I've got 2 points it goes through and it's a line. The other one is a parabola that opens how?
Sideways.
True. Facing which way? Opening which way?
To the right.
To the increasing x's, yeah, so it's going to open this way. So if I just plug in, I think what I did was, do you see how this is -1 and 2? Right in the middle of that is 1/2. And if you plug a 1/2 in, you get 1 plus 1/4 is 5/4. So basically right there, so now I've got this, because it's a parabola like this, and I found like a middle point. So I just need a quick visual anchor. Okay. And the reason I do that is I know this is a straight line, and then students are like, well, does it do like this or does it do like that? And a lot of students just guess. And all I gotta do is pick a number in between, plug it in, and see what you get. So when I plug y equals, what did I just say? When I plug y equals 1/2, I get a 5/4 out for x. So that's why I put it right there. Okay. So now I know it's curving that way. What did I want to do with this region?
Rotate it
Y-axis? Okay. Oh, that's right. Yeah. And I want to do integral dy. And right now, if I do discs, it would have to be integral dy because I'm rotating around the y-axis, yes? That is the key thing. That is the thing right there. That's the step that puts everything together. If you want to use discs, it's got to be integral d axis of rotation. And of course, or parallel to, yes? Okay. So any straight up and down line, discs is dy. Any line, flat line, discs is dx. So you're like, I don't want dy, then you use shells. If you're like, I want one, then use discs for this problem. And I do want to keep my functions as functions of y because I don't want to solve that for y. I don't want to make a function of x because then it gets trippy. So we're going to do discs. Do you guys follow that decision tree? Maybe. So yes, I want to use discs. So what does discs need from me? What's the full thing look like? I get to start at pi integral.
Big R squared minus.
Yeah, r outer minus r inner, or you can use big and little, I don't care. In this case, it'll be dy. We already made that choice, right? A to b. So how do I get inner, outer? Where's my axis of rotation? It's right here. So I put my pen on the axis and I draw a line until I hit a wall. That's my inner radius. Feels like I'm doing a new age class. You must find your inner radius. So what's my inner radius exactly? What wall did I just hit? Yes, the curvy dude. So then what's our outer? The other guy. And now and then you just throw it in. You guys see how you're gonna get a polynomial. You're gonna have a couple of things to FOIL. On the grand scheme of things, the work after this is really easy. What's it going from to? How do you even know which axis to look at for that?
Because we're doing it in terms of dy.
Yes, dy, so you look at the y-axis, and what's the region going from to? -1 to 2. This is why I try to get students to understand. This right here controls 80% of the problem. And that's why this is the first thing you think. What would discs need? Integral dy or dx. Shells would need the other one, and then I just go, is one of those sound better? I'll do it that way. And then you can focus, if you pick discs, pi r squared. Not hugging, so it needs outer, or if it's shells, you think 2 pi r and h, then you can just sort of categorize it and kind of go to the right place in your brain and think about just that kind of problem. Okay, maybe. So pretty cool with this? We're to the easy step now. We're to the part where Jeff said he was bored. So this would just be pi integral -1 to 2. Where do you go? 1 plus y squared minus y plus. I did it exactly backwards. I set myself up for failure. Y plus 3 squared minus 1 plus y squared, and then I got a FOIL, and I just get a big old polynomial. Yes? Okay. Here, why don't we do this real quick before I just totally forget? I'll give you guys, you got one right here? Yeah. Give you guys this awesome free part. And I gotta explain that there's an issue here. Huh? Sure. I gotta explain one thing here about this. Real quick, I don't really understand happened this morning was even physically possible. But do you guys see two number 8s on your answer key? Yeah. Okay. One of those is from practice test 3. I have no idea how it snuck its way in. The printer had really interesting issues, but I'm not going to blame it. It's most likely user error. So this number 8 is correct. There's after the first page, there's a number 8, yes? Then if you look at this, there's number 8 again. I think this is all from practice test 3. On the back of this though, it picks up a 10 again from practice final.
So, this entire just page.
Yeah, it's just
Cross it
take
out.
a second and find this page and yeah, cross it out. That's probably a good idea.
What page?
I'm sorry, this page. The one that starts with 8A at the top. This is from practice test 3.
Oh, the whole page?
Yes, the whole page, yes.
Even question 9 at like the bottom, right?
Because here's 9 already.
Oh, okay.
Yeah, okay. Okay. I have no idea. It really quickly, if I would have accidentally put a page in from, it should have copied both sides of it then. But somehow, I have no idea how that happened. So I'm not gonna think about it. I'm just happy you got all the right problems, just some extra. Okay. So let's look at another one while we're on this topic. Let's look at one later here. Number 16. Gaze upon number 16. By the way, number 13, their instructions said don't integrate, and you can't because it's you can't. But look at number 16. Now the instructions on this one actually say do it both ways. And that's one reason why I assigned this for the practice finals, because I had said in class that there are problems where you could do it both ways. It's easy as shit to solve for x, right? Are you guys understanding what I'm saying? Currently, we have functions of x. So then I want integral dx for the way it is. But it's easy to solve both of those for x and get functions of y, yes? Now I do have to take the square root, but once we graph this region, you'll see we're on the positive side of things. So the square root here would be positive square root. What's the even without all of what I just said, what's the very first thing I should do? Find the intersect, yeah. Find out where those two intersect. So go ahead and do that. By the way, this is the very last problem on the practice file. I think on the answer key, I got bored and I didn't finish. I set up the interval and like, you go. So we can finish it out here if you want to. So we got square root of x equals x squared. How do I do that? Square both sides. X equals x to the fourth. How do I do that?
Read it to one side and back.
Oh yeah, so get it equal to 0 and factor. Go ahead and try to factor that. Don't divide by x. Don't ever divide by something that could be 0. Because then you could be creating small black holes. So now the funny thing about this problem is, do you guys agree there's two very obvious answers? What number is equal to its own fourth power? 1 and 0. Now, the fact that it's a fourth power says there could be two other answers. But what do you get when you factor this thing? Well, it's still there, it's just broken up. There will be four answers to this. How do I factor this guy?
X squared.
No. Little dude just gets one of each. He's a little tiny dude. Other two x's here, 1 squared is 1 there. Opposite sign, 1 times x. This will always have, the big guy in a cubes will always have complex answers. So screw him. We're not graphing the complex plane. We're not integrating across the complex plane. And what answers do I get? I get the answers that were obvious, right? 0 and 1. Okay. Well, you have to do the work just to make sure that there aren't other points of intersection. So they intersect at 0 and 1. So then if I want to graph this thing, my two functions here, let me put this here just so I don't forget. Y equals square root of x, y equals x squared. So 0 and 1. Now the outputs happen to be 1 at both, yes? And I don't need this in pre-calculus. You had to be highly detailed. In calculus, if the point of the problem is to graph, you must be even more detailed. The point of this problem is not the graph. So here's a parabola goes like this, and a square root goes like that. That's all I need to know. I just need a visual. So now I know this is the x squared, and this is the square root. Now what am I rotating around? Did I do the same thing I did on my answer key? Yes, I did. I'm just gonna put 3 up here. The scale sucks. Who gives a shit? This is a really good general, if the point of the problem is not the sketch, and you're drawing the sketch as a visual anchor, your scale can suck shit. Because you better not put the 3 before the 1, but still. I'm rotating around y equals 3, yes? So now my visual anchor allows me to do things like find where a rectangle is if I'm doing shells, find the inner and outer radius if I'm doing discs. If I want to keep things in terms of x, now, let's do it this way instead, sorry. Let's do it this way. What would discs need from me?
Dx.
I got dissension in the ranks. What am I rotating around? An axis that is parallel to the...
X.
Yeah, so it'll be dx. And what would shells need then?
Dy.
Okay, so if I leave these guys like this, I can do discs. Do you guys see that? You can always determine these just from what you're rotating around. So if all I told you was, I'm rotating around x equals 3, that's all I tell you. What would discs need?
Dy.
Integral dy. What would shells need? Integral dx. You can tell that just from the axis of rotation. And again, it's because discs would be outer and inner radius like this. Yes, I would find my discs by moving along this axis, which is moving in the x direction, dx. And maybe. So let's do disc method first. Can you guys help me? How do I know there's 2 radii that I need? My region?
Is bounded by 2 functions.
No, because sometimes that actually works, believe it or not. But my region is not hugging the axis of rotation. So I got a hollow middle. I already made the joke about that describes me, so I won't do it again. So, how do I find my radii? Where do I always start no matter what? Don't be laughing at me. Yes, start at the axis of rotation and just draw until you hit a wall. Now, this is where students freak out. Do you guys all see the wall I stopped at? What's the definition of the wall I stopped at? Square root of x. This is going to be my inner radius, yes?
Inner radius.
how long is it? How do I tell how long between two things? I take the bigger minus the smaller, yes? Which one is bigger? This wall's outputs or 3? Which one's bigger? Don't think about it. Which one's bigger? 3. So, how long is this? 3 minus square root of x. If my axis of rotation was down here, what would be bigger then? If my axis had been -1, x equal -1, then this would have been bigger. Then it would have been rad x minus -1, rad x plus 1. It's always bigger minus small. Always. People always make this huge deal out of this, and I don't think I quite said that though. Of course, I was throwing a lot of shit at you, but does that make sense? Okay, so this will be my inner radius is 3 minus rad x. So what's my outer radius? Yeah, 3 minus x squared. And I think this is where I basically stopped on the answer key, because at that point I don't care. So it's integral dx with a little pi outside. So what are my bounds for my integral?
0, 1.
Yeah, what's x doing is going from 0 to 1. And it would be r outer squared minus r inner squared. I'm really worried about past Jeff. Was he okay? Did I get those turned around? No, I did it right. Look at me go. Look at me go. Oh wait, did I just do it wrong? Oh, I did it wrong there. Damn it, Jeff. I knew it. These should be turned around. I think at this point it was like 8:30, and I was like, I gotta get going. I don't know why I did that, but the outer radius comes first, and that's the x squared part, and the inner radius comes second. Okay. How do I? And now it's just, I'm not gonna get a polynomial, but I'm still gonna get like x to a power. So now I just gotta FOIL this stuff out. You guys with me? Yeah. So now I get 9 minus 6x squared plus x to the 4th minus 9 plus 6 squared of x minus x dx. And yeah, hopefully you understand what I mean when I say I'm disinterested. Yeah, we know how to do an integral, and then you plug a 1 in, and who cares? That's easy. Everybody can do that. Okay? I always get one big mistake I see people make, and I think it's because your brain says, I've done so much work already. People just start throwing a 1 into this, but you haven't taken the integral yet. You haven't taken the integral yet. So don't start plugging into that function yet. One nice thing here is the 9s cancel, yes? And I think that's the only thing we can put together. So then, I mean, if I want to integrate this, it'll be negative 2x cubed plus 1/5 x to the 5th. This is x to the 1/2, which become x to the 3/2 times 2/3, so 4 minus 1/2 x squared. That's exciting. And then I just throw a 1 in there. Put it in my calculator. Put it in my calculator. No, 1.6. Yes?
On the final, are you gonna give us the equation of like the disk shells and stuff? Like,
Oh, yeah. I'll do the same thing. Yeah. I did it for you on the quiz. I'll do it on the last test. So I'll do it on the final. So really, the parts where students get lost normally, unfortunately, sometimes it's this step Which is why on the test, I said verify algebraically, because I'm like, same way I say like verify f prime and f double prime, because I want you to be able to do the rest of the problem, even if the first step gives you trouble. Because if you don't find the right places this intersects, everything's going to go to shit. So I might do the same kind of thing on the finals, just verify this is where these intersect. So if you can't, you can still do the rest of the problem. This would be probably a good place because people always forget how to factor this guy. Okay. And then it's just not being nice to yourself here, which I wasn't when I made this because I made this too small. So then I lost track of which was which. But as long as you're kind of nice to yourself, right? It doesn't have to be overly detailed. It just has to have things in the right relative place, and then it's a visual anchor. See you guys. What have we not done? Oh yeah, we didn't do the. I don't blame you because I think this problem you guys probably could do the one where you have to find your cavity and increase, decrease in max and min. Yes.
Are you gonna have anything about the thing with delta and epsilon?
Oh, if I did, it would be a bonus. I always want, and I didn't assign that much homework because it's just laying groundwork. Because there are theorems that rely on the epsilon delta to be an understanding that just represent close in the x-axis, y-axis. So as long as you got a feel and you went through the process, later theorems that rely on that, you'll have a better connection with them. Yeah. So it's not a major thing I need you to know how to do right now. It kind of depends on, if you go down a purely mathematical route, then that would be like a baby level proof. And if you understand that, then you can jump into other stuff better, right? But it's not a major thing for like pure STEM maths that aren't math. You don't need that for everyday thing. Yeah. Of course, you guys are like, what do we need here for everyday things? All this stuff is my everyday.
What about 9B?
Oh yeah, I like that one. So, I mean, is there an obvious thing you can do right away?
Yes, but upon like looking at it further, it doesn't seem what would make most sense. If you let u equal s squared.
Oh, I see. Don't do that because S isn't in there. Now, when I say that, students won't freak out and they'll go, Jeff, are you all right? I see an S right there. No, I see a 1 over S. I don't see an S. So that S is on top, that would make sense. But I mean something more fundamental, not even calculus. What do we do when we see a natural log? We try to use properties of logs to simplify it. So what would I do?
Take out the 2.
Yeah, then, so this would be 2s ln s. Now do you see a function whose derivative is in there?
Can you do lectures?
Yeah, we're doing it. I just wanted to see how far we can get. So I
Yeah,
can,
natural log.
and to be really honest, if you let u equal this from the beginning, it would still work, but it's just a little bit better to take the 2 down. If you let u equal natural log, what's du?
1 over s.
Now that is what's actually in here. I have an extra 1/2 I'll just take out the way. 1 over, this is u, this is du. Now what's the integral of 1 over u?
Natural log of u.
And of course, what was u?
Natural log of s.
Yeah, there you go. And that's where students also freak out, because they're like, how can you do that? Well, of course you can do that. Of course you can do that. What can you get that natural log of? Anything bigger than 0. Now, just to show you, if you had let u equal ln of s squared, du would have been 1 over s squared times 2s, so it would have been 2 over s. And I have an over s, I just don't have a 2, so I would have needed to put a 1/2. See how mathematically they end up in the same place? Yeah. So there's two kind of main ways to do this problem. I just always look, simplify my logs if I can. That almost always makes it better. Yeah, we talked about every single problem on here, haven't we? Yeah. Let me see. Yep. Damn. We didn't talk about number 7, but maybe at this point people feel better about number 7. I'd much rather see an optimization problem than a related race problem. It doesn't mean as a student I couldn't handle a related race. It's just if I had an option, I would pick the freaking optimization, didn't it? So when you see, I'm not going to bold it obviously on the test, but when you see minimize, maximize, greatest, small, whatever, then you go, oh good, okay, tell me, focus, ask me, focus. Use what they tell me and what they ask me, derivatives. I mean, it's a very recipe-ish structure.
So you're gonna make like a rectangle? And
Yeah, you can draw a rectangle, give it dimensions, give it variable dimensions, yes.
And we're gonna make it.
And you have two ideas. You have area and you have cost.
Be like xy equals.
Yeah. XY equals,
Like 108.
yeah. And now set up the cost function. And you get to pick which side is going to be the cheap side. For one reason, one side doesn't need like expensive brick wall.
Then we're gonna like find the total cost. Oh yeah, okay, almost cost.
Yeah. So in this problem, I want the dimensions and the cost.
Let's do it.
Huh? Okay, we almost just now finished it. Let's see. So like you just said, 108 equals xy. You help me out. Which side do you want to be the cheapest?
The y.
This side, okay, I'll say this side is cheap. So they tell me this, and they ask me about cost. What's the cost of this then? So let me be more specific. This was 15 and the other was 30?
It was 30 and 15, yeah. Wait, so, yeah, so on 3 sides, it's 30 and on
Sure, so what's the cost function? How much does this side cost total?
Oh, okay. So,
How much does he cost?
So it's gonna be like 60 and.
No, don't say 60 and. How much does this side cost? Don't tell me $30, that's wrong.
Just 30.
No, that's if it was 1 foot long.
Why?
How many feet long is it?
Why?
Okay, if it was 2 feet long, how much would this side cost? How much per foot is it?
30.
Is it feet, right? I can't remember. Right? $30 per foot? If it was 2 feet long, how much would it cost? $30 per foot, 2 feet long. How much would it cost? 60, good. If it was 3 feet long,
90.
3 times 30.
90.
If it's y feet long,
So 31.
there you go. So
Oh,
we
yeah.
got 30y plus 15y, yes?
Okay, so it's 45.
45y. What about the x's?
60.
60x total. Good. And now you can use this. How do I use this? What do I do with this so I can use it?
Equals 180. We're gonna put like an equal to 180 or.
What equals 180?
No, actually, no.
What is 180? 108.
We're gonna do the like derivative.
No, 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 no. What is wrong with this equation? Now, why do I not want to do this guy's derivative? How many variables do I have? Too many. I have too many.
What about if it's like dx dy? We don't want to do that.
Well,
What
you
if,
you don't want to do it. So, what can I do then? What do I always do? I could solve this for a letter.
like,
Tell me what letter to solve for. X, so I divide by y. So I know x is 108 over y. Wherever I see x, I can replace it with this. Do you see that?
yeah.
So now my cost will be 45y plus 60 times 108 over y.
So it's like.
Now in the answer key, what I always do is I don't multiply this shit because I know later I'm gonna have to divide and stuff.
So you just plug in x to the 180.
108.
Over y.
Yes, because I know that's true. If 108 has to be this product, then one of them is 108 divided by the other
Choose
one.
y, right?
Huh?
We can also choose y.
Of course you can. It's completely up to you. It's just if you choose one or the
Which
other.
one will like make it easier depending on.
I don't. It depends. Yeah, yeah. If you notice something about the numbers that makes one easier, then do it that way. If you don't, then pick a way and just do it. The level of difficulty can't be that different. Yeah. And what do I do with this now? I have a cost function, and I want to minimize it.
So are we gonna take the derivative?
Yes, totally. Yes. So from the beginning, oh, I tried to take my glasses off. I never put them on. From the beginning, it said minimize cost. Okay, I gotta focus all my attention on setting up a cost function. To help me do that, tell me, ask me. I got my cost function. How do I minimize anything? Take its derivative, find critical numbers. That's why everything we did went into this cost function, because now when I got it, I know what calculus to do to minimize it. Take its derivative, critical numbers, second derivatives, tell me that it's really the minimum.
Do we need a second derivative too?
I don't know. If you don't do it, I'm not going to take one. I don't think I did it wrong. Yeah. Almost always, these will work out the right way. But, like I said, in real life, you want to double check to make sure you're not going to lose your company millions if you do something financially related. Is that okay? I mean, the rest of it's on the freaking answer key. I'm pretty sure this is exactly the way I did it. Derivatives, pretty straightforward. Yes? Okay. So, no, I won't do it a second time. Or I did it on the answer key. Okay.
Are we gonna have a question on the, like, that's like, we have to find the second derivative on like economic umbrella and like can't give down, can't give up, and make a snapshot, right? For
Yeah, I just wish I would have communicated to you somehow that that's a possibility. You mean this problem?
Yeah.
All right, there you go. Yeah. So are you asking me if I'm going to definitely put that problem on there?
Yeah.
No. Okay, we'll find out tomorrow.
Because like for the entire semester there's like a limit and like derivative and like antiderivative and like the word problem like the relative rates and
Sure.
like,
Yeah.
this.
Sure.
How are you gonna fit? So you're gonna choose, huh?
Yeah, I'm going to have to let something go.
Yeah.
Yep.
What if you did this and shouldn't did them?
Or you want to make recommendations as to what I should let go?
No, not this.
I won't accept those. In fact, you should not recommend to me something to take out because I'll make sure that it's in.
Okay, at least
That's why somebody told me something. I thought to myself, is he being smart and saying the opposite of what he means? That would be smart.
No, like so how many word problems is there gonna be that just has
7. No, it's gonna be. Just imagine it's gonna be maybe at most 3. You know, there's gonna be a related rates. You know, there's gonna be an optimization, and there could be a third one that, if there is a third one, that to be pretty short and sweet. But you know, there's gonna definitely gonna be 2. Maybe there will be a third one you would call a word problem. Does it make sense?
yeah.
Okay.
Are you gonna have like a question that I mean of course you're gonna have like to find the derivative using the limit definition? Like we did at the first test. So we can
I don't know. Is it on the practice test? Oh yeah, it is on the practice test. I need to say this. If you ask me if I'm definitely gonna have a certain kind of problem on it, I'm not gonna tell you. So we can just cut all those questions out.
Cut this question.
Yeah, so what could be on this test? Everything we've talked about. What will be on this test? Less than that, because we don't have that kind of time.
Yeah.
What will be on there, then Jeff will plan this more. The minute you get that, you're like, oh, we put that one there. Jackass.
How long are you gonna stay here? If I do the test correction and give it to you, are you gonna stay until like 1:30 or are you gonna leave?
No way in hell. Sorry, buddy. But,
You're gonna leave as soon as we leave?
well, I'm gonna upload the video, see you? And then I'm gonna head out, yeah. Cause you got tutors and stuff that can help you too. I'll be here tomorrow early again, right? Now, if you have specific questions, I will be in my office for a little bit. We can do that. I'm just not gonna hang out here for like 40 minutes or so. Yeah. See you tomorrow. How you doing, Dylan? Good? Now you see why, you see why you see why I asked, yeah.
I have a question.
Yeah.
Can you do a this method problem?
Another one? Sure.
But like each step like explain it like you know.
Alright, let's see.
Before and that's the last question.
Alright, here we go.
And how do you know it's like if it's like this method? In case you're gonna put like or use do it by this method.
Let's see.
And he said like there are problems that we can do shell method or this method, and we get the answer.
Dude, what? Say again?
And he also mentioned the other day that there might be a problem that we can solve it by using shell method and this method.
Yeah, we did one earlier. Okay, let's do this. Let's do a nice straightforward one. So let's say I have these.
What question is it from the book?
Yeah, this is number 7 on page 479.
Number 7, page 479.
Yep. Let's say I want to rotate this around the x-axis. Right away, before you do anything, you know exactly what disks would need.
So do you took the antiderivative?
You are nowhere near that step yet.
Oh, because 2x, actually, no.
All right, focus. What am I rotating around?
X.
Disks will always need integral D thing I'm rotating around. If I'm rotating around the x-axis or something parallel to the x-axis, disks will need dx.
What if it's like y-axis?
Shells would need dy. What do you think?
Y-axis.
What do you think? What would happen? If I was doing it around the y-axis, what would this be?
dy.
Yeah, there you go.
So, like, if it's like around y-axis, we can say
Disks would need dy, shells would need dx. That's why I tried to say, if you just write what disks need, how do you know what disks need?
So,
What are you rotating
so
around?
it's the opposite.
So if you're rotating around something that's flat, like this, anything, y equals -3, y equals 7. If you're rotating around anything like this, disks needs dx. Shells automatically would need
Opposite.
dy, the opposite, yeah. So no matter what the problem is, before you do shit, you can write down this for yourself.
Okay.
You with me?
Yeah. Can I just see the question? Sorry.
Oh,
it's not
let me put it up here.
Oh.
It says exactly what I said, but I mean, it doesn't give us anything else. Look,
Find the volume.
2x,
Find the
y
volume
squared,
of the-
around the x-axis. That's what I've already said.
So it's gonna be like find the volume.
Yeah.
Okay. So there.
That's why we're talking about disks and shells. That's what they do. So now we know, well, okay. You could solve these for X and use shells, but they're sort of already set up beautifully for disks because they're already functions of X, yes?
Mm-hmm.
Okay. What do I do next?
Do the integral.
Nope. You are nowhere near that. We haven't set the integral up yet. Take the antiderivative of what? We don't know yet.
So we're gonna set something to like.
Listen, how do I determine where this starts and where it stops?
Make a graph.
How do I make a graph?
Sketches.
Sure, but what would be really good to know? We're trying to
Are we gonna do 2x?
rotate the region that this catches.
We're gonna do 2x equals x2.
Yes.
We also did this. We also did this different problem, right?
Yes.
But so how do you know the difference?
So anytime you're trying to find a region defined by two functions, you have to see where they intersect to know where it starts and stops.
So the region was that one, but this is volume. We still do that.
Is this talking about a region that these two capture? Yes, and then I want to rotate it. So in this case, I still need a region that those two functions capture,
Okay.
right? And there's several different kinds of problems that want that. Anytime I need that, I don't care what I'm going to do next. Anytime I need that, I have to set them equal to each other, figure out where they stop and start, or other way. So how do I solve this?
So we're gonna just solve for x. I mean.
How do you do it? Tell me. Don't
So
just
we-
say solve for x. How do you solve for x?
So we're gonna do minus x.
Minus x?
Oh, like minus x squared.
Okay, sure.
Now we're gonna factor
Yeah. How do you factor?
x parentheses 2 and minus x. You want me to say square? Okay.
Well, why would you say squared? You took an x out.
Because you put your pen under there.
Well, I'm just waiting for you to say something.
Okay.
You should have said that's it or something.
And
Yeah.
Now we're gonna find the critical now.
Yeah. I mean, yep. How do you do that? Now you're just going to solve this out. The
Zero.
critical numbers are
Zero and
not.
two.
These are not critical numbers, by the way. These are
So 0 and 2.
total. So now, if you go to graph this, you know you only care about 0 and 2 because that captures the whole region.
Why do you put the 1 there?
Because one's in between.
Oh.
That's all. So from 0 to 2. How do you graph this? So where is it? What's the output at 0?
2. Wait.
When you put a 0 in.
Oh, 0.
What's the output when you put a 2 in?
4.
That's crazy.
Yeah, 4.
Bam. So there, that line is graphed. How do I graph this? Well, I know this is where they both meet. But now I just need to graph this. And how does that look? How does a parabola look? In fact, you can even just put, if you put a 1 in, you get a 1 out, yes? So it's going to be like this, very skinny.
Discussion, it doesn't have to be perfect, right?
Nope. Just need a visual anchor. I'm rotating around the x-axis. What do I need to find now? And we know we're using disks. We're not using shells.
So we need the formula for this.
Yeah. And I would put this on the board. On the board, I would put this. That's what I would have, or on the test I would have this, yes?
Yeah.
What situation are we in?
Is both of them disk? Disk method?
Yep, they're both disks. This is one disk, this is the subtraction of two disks.
So what is the difference between and how do you?
Well, one of them's got two disks, the other one's got one. So this one I'm subtracting because I would have a hollow middle. So if I rotate this, wouldn't the middle be hollow?
Yeah.
Yeah.
So you can use that, but for that is for if it's like without the hole, without the.
What's the matter?
So the this method is without the space under it, like.
If your region is hugging,
Then you can use the left one.
then you use this one because you only need one radius. If the region has space between it and the axis, you
So
have
we have
two.
to graph
Because if
the-
I start at the axis, I hit that wall first. That's my inner radius. If I start at the axis and go past that wall, I hit that wall next. That's my outer radius.
So that's what you use. You're gonna use the minus one.
Yep. Because they have two walls I can
Is
hit.
it possible if we sketch it by the calculator, by using calculator? Is it like how do we do that to get that sketch?
Yeah, of course you can. You shouldn't need to, but you could. So let's see. What's the outer radius then? What's the outer radius? You know, it's that second wall.
Just
Which one was this one?
that was like what point do we?
Where are my functions that define this problem? What are my functions? What are my functions?
X and Y.
No.
That was
What are my functions?
2x and then.
Yes. Which one's this one? This outer radius.
That was the problem was x squared.
Is it straight or is it curvy? This wall here.
Oh, the straight one is 2x.
Yeah, the straight wall here is straight, so that'll be 2x. What's the inner radius then? The
That's
curvy.
X squared.
Yeah. So now you just plug those in and do the integral.
That's it.
Yeah, totally. Yeah, once you determine, in fact, we determined it was going to be dx, and we just determined what the radii were. Plug it in, do the integral.
What about the b minus? What about the y and b minus?
Oh, yeah. So what is x doing to get my whole region? What is the beginning x and what's the end x to get this region?
That's b minus a.
No.
Like 0.
If I was looking at y, do you see how the region starts at 0, ends at 4?
Huh?
Okay, are we looking at y?
Yeah.
Are we?
No, we gotta look at x.
So what defines the region?
So 0 to 2.
There we go. So it'd be 0 to 2. So the integral, 0 to 2, 2x squared minus x squared squared. Square, integrate, plug stuff in. Yep.
So then.
Now it should be the easy step.
So when you do this problem, you're gonna skip the sketch problem. You're just gonna. You already know like what's the outcome gonna be.
If I do what?
So like when you like do this problem, right? You already know like the fast way. So you're just gonna plug in this number.
Are you asking what I would do?
Yeah, I mean just like the more you do it, you're gonna know the pattern of.
Sort of.
And so.
I still like to give myself a visual anchor to make sure I don't make some kind of
Yeah,
assumption.
absolutely.
Especially if it's in terms of y, because I haven't graphed in terms of y as much
Because
as
we just plug in the 2x and minus x squared into this method function. We don't even like need to like. If we find like an easy way, we can just plug in, right? I mean, I'm just asking, you know, I'm trying to.
Yeah, I know. You're always trying to find the easy way around. But yeah, the more you understand the parts of this, the more straight to the thing you go. The less work you show me, the more I have to assume everything went wrong if something goes wrong.
Yeah.
Yep. So the more work you show me, the more I have to work with, the more partial credit I can give.
Yeah.
So it's up to you.
For now, I have to do the work because I don't know the like easy way. But I seen it that if you do it more, as
No,
soon
of
as
course,
you know,
it's like anything. If you
Yeah.
do something enough,
as
you'll
soon as you know.
know where it's headed.
Yeah, as soon as you know if you like use the minus method or like the plus method, then you can solve it without doing the derivative or without trying to.
What's minus plus method?
So I mean like the right formula and the left formula. So as soon as you know like what
Yeah.
to use one, then you can just plug in the what's given and solve it without doing all of this stuff. So it's gonna be like easier problem with that. But that
Everything is
that requires
easier if
more-
you do it a lot.
But
Yes.
that requires more practice, right?
Like everything.
But for now, I have to do the work.
If I try to play a violin right now, it'd be very difficult.
If you play what?
If I try to play a violin right now, it'd be very difficult. If somebody's played the violin for 20 years, they could probably pick one up and just do almost anything with it that they wanted to. So it's just like anything. The more you do it, the quicker you could do it.
Yeah. But for now, I know I'm not ready to do that.
Exactly. So you want to be kind to yourself. Give yourself visual anchors.
But you know, like on the test, it's not gonna be like straightforward. It's gonna be an word problem.
What do you mean?
Right?
These can't be in word problems. These are not word problems. These are find the volume obtained by rotating the region defined by these around the y-axis or whatever. These are not word problems.
I just wanna make sure. I'm trying to look for my test, and there was a problem that was about the graph and word. I just want to know like how you put it, and like this method on the test, and how was it described for us to like solve it.
On the last test?
Yeah. Do you have like a student example or like I can't find mine.
On the last test.
Yeah, from the last test. Example C. It was like I want to know like how you put this method for us to solve it.
See, Dill? Here.
Do I leave my exam there?
Huh?
Do I leave my exam there?
I don't know, dude.
Sorry, Professor.
Alright,
I'm just
so
trying-
here's the, see, this was one of the two disc or shell. This was the shell method here, and this was the disc method here. Is it a word problem?
Oh, okay. So this two our thing.
Can you set them equal to each other so you can figure out where they meet? Yeah.
Yeah.
It's about the,
Can you teach me the easier way to find if there's like a space on Earth? Or
if there's a what now?
If there's like a space here, like here,
A space in here.
like here, like here. How do you know, like from the beginning, that this question might have a space there, or just?
What do you mean a space there? Listen, I didn't even think about it because I knew we were going to do all the steps. So I didn't even stop to think to myself what that was going to look like. So we graphed it, and then I knew what it looked like.
Right.
I don't have to know ahead of time. There's no reason to know ahead of time.
Yeah, but like.
No, listen. If you want to try to develop a way to skip some steps, that is on you. Right?
But I need your help, you know, like.
No, I'm not going to help you figure out how to skip steps. That is something you do after you've done enough, and then it makes more sense, and then you can skip steps. Right? I'm not going to teach you how to skip steps. That is something you develop after you've done enough of the problems.
But you know, maybe if it's just positive, then it's gonna be that, or maybe if it's minus, it's gonna